How's it going today? This is Kevin. I'm a current software engineer at Google and an alumnus of UC Berkeley, where I studied EECS. And today I'd like to talk about the LeetCode number 2, adding two numbers, and how you would solve this question in an interview, for a software engineering interview. All right, so basically for this question, what we need to do is we get two numbers and they're represented in the form of a linked list. So right here you can see the example. They give you a linked list with a node of 2, and then the next node in that list is 4, and then 3. And then this is representing the number 342, so it's just kind of reversed like that. And then they give you a second linked list, same way, where it's represented in, it's representing the number 465, and the output would be 807. Represented, 708, like the reverse way. And so one of the prereqs for this is it'd probably be best to have at least a basic understanding of a linked list. In the question, they actually give you a definition of what a list node looks like. If you don't understand what a linked list is, I'd recommend maybe taking a look and brushing up on that first, or if enough people comment on this video and want to understand what a linked list is, I'm happy to make a video explaining it as well. But I'm going to go ahead and assume that you already understand what a linked list is. All right, so for this problem, let's kind of try to figure out how would you do this if you were just doing this in regular math, for example. So let's see here. So you have 2, 4, 3, and 5, 6, 4. All right, so basically you would, if you were doing this in regular math, you would take the ones digit here, add that together, and you get 7. Then you add these together, and you get 10. And so what that ends up being is actually 0, right? And then you carry the 1 over, and then you get this, add this together, you get 7. But you have a 1 that you carry over, so that's 8. Actually, it might actually be easier. So then you get 807. So another way to represent this is, like, let's say this is, the sum. Here, I'll line this up. And you also have a carry. So when you do 2 and 5, you get 7, and you carry 0 over it, right? Then you add 4 and 6, it's actually 10, but then you carry which then you take, the sum actually becomes 0, and then you take the 1 and carry it over. Actually, let's do this. Sub, there's not enough space here, sub. So this will be the sub sum, which you don't, so it's like this. So 7, right? 2 and 5 is 7, 4 and 6 is 10, 3 and 4 is 7. And from that, you get the sum that's going to go into your actual output, which is 7 in this case, 0 because you take the 10, you carry the 1, and you keep the 0. And then in this one, this is actually 8, which is 3 and 4 makes 7 plus the carry from the previous to get 8, and then you get 8. And so this kind of helps us get an idea of what we really need to do. We basically add and we get this sub sum, and then to calculate from the sub sum into the actual output sum, which is this row, you basically do a divide, actually a modulus operator. So that would be something like sub mod 10. And what that does is basically just, what the modulus operator does is divides this number by 10, and whatever the remainder is, that's what it outputs. So if you divide, when you add these two numbers, the biggest number you can possibly get is it's 2 9s and a 1 carry, so that would be 19. So it's basically going to be a number between 0 and 19, and when you mod by 10, you just get the ones place. So in this case, you get the 0, right? You get the ones place. And then what do you want so that's how you get from the sub sum into your sum. And what do you want to do to get from your sub sum to your carry? Basically, that's just, if the number is bigger than 10, the carry is 1, right? If the number is 10 here, you carry 1. If the number is less than 10, like in this case 7, then you carry 0. So that's also pretty straightforward. You can just do, in Python, the division is actually an integer division, so you can just do this, the subsum, divide by 10. And so like, let's say it's like, the sub is like 15 or something, you divide by 10, you think that's 15 over 10 is 1.5, but actually in Python, it will just floor that down to, from 1.5 down to 1. So basically this just works as, if it's greater than 10, you get 1, and if it's less than 10, you get 0. In other languages, you might need to use something like math.floor or some equivalent of the number divided by 10 to get the integer value of that. All right, so hopefully that makes sense in terms of like how you would kind of come about coming up with the algorithm for this. Like you calculate the subsum, use these calculations to get the sum and the carry, and then kind of just iterate through each item in the node. So why don't we try, as a next step, try coding it up. All right, so let me just check my notes here. All right. So let's do it like this. We'll have a carry bit, or a carry value, your sum, right? And we're also going to need to output this into a into a linked list. So let's, the way I like to do it is actually have a dummy node. So how this works is we're outputting this 708 thing, but before this I also have one other node, which is the dummy. Wait, let's do it like this. Dummy node, which points to the first node, which points to the next node, etc. Right? And if you do it this way, you'll see it's just kind of, you don't have to like make a special case for the first item in the node. So this is kind of how I like doing it. Anyways, we'll create a list node. We've already got the list node API up here. The list node is just an object that has two things in it, the value, which is the number, and then the next points to the next node. And you can actually initialize the value with something, but I don't really need to do that. Right now, the dummy node doesn't need to have any values, so these default values that it initializes to are fine. And then I'm going to also keep a pointer to my current node. So I'm going to call that cur, and right now it's just pointing to the dummy node. And this is going to be my output. All right, so now we need to do this addition part. So we're going to iterate through L1 or L2 or C. So these are L1 and L2 are the inputs. And if any of those is not null or none in Python, then, and if you have a carry bit, then you have to do one iteration of the calculation. So let's do it like this. All right. Okay. So sum is going to be your carry, and then you also need to add an L1 and L2 values. And right now I'm going to use sum to calculate the subsum, but I'm not going to create an extra variable. So it's just going to be if L1, we have to do some null checking. So if L1, because in case L1 is actually null, then we don't want it to enter this part. S plus equal L1.val. And that's because if L1 is null, if we do L1.val, we're going to get, you can't, the null object doesn't have a val in it, so we don't need to worry about that. So we just do this the null check first. And so we do the same for L2. Okay. So now we basically done this operation of adding this, and the carry to get the subsum. So now S represents the subsum in this case. And so what we need to do next is we need to calculate the sum and the carry by using these two operations. So your carry is now going to become, which one was it? Sub S over 10. And then your sum is now going to be equal to your current sub mod 10. And so you're currently, so you want to point to the next node. So it's going to be cur.next equals list node, a new list node of S. And actually, we don't even need to do this. We can just put this directly in here. So let's just take that in. All right. And then advance the cur node by the next one. So what's this doing is basically your current node is pointing to the dummy. Now you're pointing to the next one that so you just created this one, this next node, and then you're saying the current node is now pointing to this node. And then the current node will keep pointing to the next node as you keep on creating each next node. So that's what you're doing here. So I think that should be it. So carry is, so you calculate your carry, you calculate your sum here, and you put that into your output node, and then you advance the pointer. Great. And then once you get to a point where there's no L1, there's no L2, and there's no carry, then you can stop iterating, and then you would return dummy.next. So let's try that out. All right, so it worked for this basic example. Let's see here, was there anything else I was going to cover? Let's just go ahead and submit this then. Let's see if make sure that's working. All right, cool, it worked. So let's also talk about a little bit of the time and space complexity of this. So for time, basically what you do is you have your two inputs each with n nodes, we'll say, and one could be bigger or smaller than the other, but basically we would do this one calculation each time for each node, basically. So you're doing one calculation per node, so if you have 100 nodes, you would do 100 calculations. So this is basically going to be n time, linear time, okay? And in terms of space, you basically, let's see here, technically you are creating a output node, which is your output. You have to create that, but in terms of the actual, let's say if you disregard that aspect of it, it's basically you're not doing any other calculations. But actually, let's just call this linear time as well, or linear space as well, because you actually have to create the output nodes and the output list here. So we'll call that space n as well. Okay, cool. So I think this is basically, in an interview, if you got to this point and were able to kind of discuss the time and space complexity and come up with the basic algorithm and explain it, I think you would be doing fairly well here. I think as a next step, maybe you might want to just go through some test cases. So I'm going to go through a few test cases and then maybe go and dive into some extra credit that might come up. So let's go ahead and do that. So let's call this extra credit. All right, let's go with test cases first. Test cases. So let's say you had two numbers, like just some of maybe the basic edge case testing. Like, okay, let's say you had two, which were like 0, 0 as your input. What would happen there? Well, you'd basically have a node with 0. So you would go and enter into this iteration. You would do the calculation. You would basically end up with 0 for everything. You would create one node right here where the value is 0, and then you would return that 0 node. So that's one way you could do it, and that would work. What if you were to be given just a null object for both of the inputs? So what would happen there? So L1 or L2 are both not they're not truthy values, and then the carry bit is also a 0 to start with, so you would actually not even enter into the while loop, and you would just return dummy.next, which is going to be a null object as well, or a null value. So you would actually get null here, or none in Python, which is actually fine. I think it's really kind of up to the user to say like what you should get for these kind of weird edge corner cases. This may not even really be a valid input. So I think those are kind of like the main basic edge cases. Just, if you want to walk through these with your interviewer, you can kind of just show that you can understand your algorithm and have thought through the edge cases. And now I want to dive into another interesting edge case here. So let's go back to the description, make sure we have all the info. So let's say we have this, 2, 4, 3 thing, 5, 6, 4. But what if we had an input like this, where one side of the input was way, way longer than the other one? All right. So this is going to represent some like this represents the number 1, 0, 0, 0, 3, 4, 2, and you add that with 564, right? So if you're really just basically doing the math, you would say, okay, cool. Oh, this is actually 465. Okay, this adds up to 7, this adds up to 10, 0, carry the 1, this is 8. And then you don't have anything else to carry forward. So you could, if you were just doing this in a math class, you would just bring this part down, right? And you would get, after you did the calculation here, 807, you're moving forward, there's no carry, so you just know it's going to be, 1, 0, 0, 0, 807, right? And so the way our algorithm works right now, it actually does this iteration. It enters the loop each time, as long as one of the list nodes is valid at that point. So it's going to keep entering into this loop here, and it'll, and actually let's illustrate that out. I want to illustrate that. So let's calculate how many times we enter this loop. So times plus equal 1, and let's print out before we exit here how many times. And then let's change this. Okay, so let's use this main base case first and see. All right, so we get 3. We iterate through the loop 3 times, right? There's 3 numbers. But what if we change it, like we said, add a bunch of leading zeros to this guy? Now what's going to happen? All right. So you can see, right, it iterates through 9 times. And so although our time complexity is O of n, and this is still following that, the n becomes 9 when one of the inputs is longer. So basically what's happening is you get the worst case situation, the worst case of your input. Your runtime becomes the worst case of your input. So your worst case is like, your worst case runtime is going to be based on a longer input, essentially. So this is actually an opportunity for some optimization. And this could be kind of like your extra credit if you're in an interview, if you can point this out. So in this specific example, we already know that, if we're adding this up, this part we'll just bring down because we don't need to do the carry anymore. So how can we do that? So basically what we would say is the conditions to exit early from our loop essentially would be, so the idea is we want to do an early exit so that we can bring down the worst case situation. So what we could do is essentially at this point, you already know that if you have one list that has a value and the other list does not have a value, and if this was all 9s, for example, and you had to carry something over, then you would have to keep carrying it, and you would still need to enter the loop. But if it's something that's like not a 9, then you should be able to, or if you don't have to carry anything over, maybe probably be an easier way of explaining it, then you can just break out of the loop. So I've actually prepared a little thing for that. All right, so let's go ahead and just put that in here. If not L1 or not L2, right? So we already know when we're entering into the loop that L1 or L2 or C is going to be a truthy value. But if it's not L1 or it's not L2, and we don't have C, so that means we have one of these two basically. So basically in this situation, and we don't have to do the carrying part, then we'll basically be able to exit. So we can just say carry.next equals L1 or L2, whichever one is the 1, and then we'll break out. So what that means is basically saying like, hey, we've constructed the node up to this point, right? 7, 0, 8. And now at this point, L2 is actually empty. So we still enter the loop because L1 is valid, is truthy. And then if we go in here, we say, okay, if not L1 or not L2. So in this case, not L2 is true, right? Because L2 is we've already got to the end of L2. And not C, which in this case, we're not carrying anything anymore. So this helps us get rid of the case if we have a bunch of 9s, we would still continue through the loop. But we're not carrying anything. And then you basically say your next node here, you can just have this point directly to this. So it's going to be 7, 0, 8, and then boom, rest of the list 1. Current at x equals L1 or L2. Whichever one is the valid one. Only one of these two will be valid. And then you break. And then you're going to return dummy.next. So with this thing in place, let's just go ahead and see how many times. So now, right, we only iterate 4 times. We do the calculation here, and then we get to this point, and we do the one last calculation, and then attach the end of our sum to the end of this guy, and then we get this number. So that works. So I'm just going to go ahead and let's actually just close out. Let's take out times, and so let's delete times. And let's just submit this and just make sure it works. Cool. So it still works. And so this one, in terms of the complexity, its time and space are basically still it's the same. But the one thing in the interview, what you could say is basically, okay, well, although the general case time complexity is the same, your worst case, or I guess actually there are cases that can be optimized essentially, right? Maybe your best case, I guess, is a better situation. Like let's say you have an input like this, instead of having to go to the end of the longer of the 2 lists, you can basically optimize and have this early exit, and so you can have some situations like your best case runtime could actually be a little bit better. Cool. So that's what I would think about for this problem in an interview, and how I would go about it. So hopefully this was helpful, and best of luck.